Okay, in this video we continue our discussion on the properties of cut sets. Here we are going to prove this statement with respect to a given spanning tree T, a chord Ci that determines a fundamental cut set occurs in every fundamental cut set. It occurs in every fundamental cut sets associated with the branches in this fundamental circuit and in no other cut sets. Okay, let me repeat. So with respect to a given spanning tree T of a graph G, okay, a chord Ci that determines a fundamental cut set say tau occurs in every fundamental cut sets associated with the branches in tau and in no other cut sets. Okay, so now to get an understanding of this statement, let's go through an example. Suppose that we have this graph G and let T be let T be a spanning tree which is highlighted in this green color. So this is a spanning tree of this graph G. Okay, and with respect to this spanning tree, the chords are E1, E4, E6 and E7. Okay, so let's take one chord to be equal to E4. So let this chord Ci is equal to E4. Okay, so let's consider this chord and the fundamental circuit that is determined by that chord. Okay, so every chord determines a unique fundamental cycle. So with respect to this chord, there will be a unique fundamental cycle. Let's call that tau, and in this case the fundamental cycle will be like E4, E5, E3. Okay, and statement says yes occurs in every fundamental cut sets associated with the branches in tau. So here the branch edges in this tau, okay, in this fundamental circuits are E5 and E3. So these are the fundamental branches in this fundamental circuit. Okay, and the statement says consider any fundamental cut set associated with the branches of this fundamental circuit, then Ci will appear there and in no other cut set. So here we can see that a fundamental cut set associated with this E5, E5 will be E4, E5, E6, this one, and the fundamental cut set associated with E3, this branch edge E3, it will be E1, E3, E4, E1, E3, E4. So these are the only two fundamental cut sets corresponding to the branch edges in this fundamental circuit E5 and E3. Okay. So fundamental cut set is a cut set which contains exactly one branch node with respect to a spanning tree and possibly one or more chords. Okay, so you can see that here, right? So here this particular cut set is determined by E3 and here E1 and E4 are chords. Similarly, this is determined by E5, okay, this branch edge, and E4 and E6, okay, E4 and E6 are chords. So here we can see that this Ci, it occurs only, E4, it is E4, it occurs only in every fundamental cut set associated with the branches in this fundamental circuit and in no other cut set. Okay, so you can see that if you consider other cut set, that is not going to happen. For example, if you consider another fundamental cut set, say determined by E9, okay, so that cut set corresponds to this thing E9, E7, E6. So we can see that E4 is not there, right? Similarly, another cut set will be like a fundamental cut set will be like E1, E2. So we can see that E4 is not there. Okay, so it will only occur in fundamental cut sets with E3 and E5. Okay, another one I think will be with respect to E8, and that cut set is this thing. So we can see that E4 is not there. Okay, so it seems like the statement is true. Okay, so let's go and prove the statement. Okay. Okay, so let G be a connected graph and let T be a spanning tree of G. Okay, so let Ci, this Ci, be a chord with respect to be a chord with respect to the spanning tree T. Okay, and let the fundamental circuit determined by this chord by Ci B. Okay, this set. So it contains Ci, okay, along with some other branch edges. Okay, and let the branch edges be say B1, B2 up to say some Bk, where okay these Bi's are branch edges. Okay, so okay, which consist of say k branches okay, which consist of k branches and the chord Ci. Okay, so that is how we define this fundamental circuit with respect to this Ci, and let that fundamental circuit be Ci. So it will contain this Ci along with some branch edges, and suppose that we have k branch edges with respect to this spanning tree. Okay, k branches and chord Ci. So we know that every branch of any spanning tree uniquely determines a fundamental circuit. Okay, so that says if you look into this fundamental circuit, okay, this B1, it is going to uniquely determine a fundamental cut set. Okay, exactly similar to what we saw here. So this E5, it uniquely determines this cut set, E3 determines this cut set. Okay, so we know that every branch of any spanning tree uniquely determines a fundamental cut set. Okay, so that says this B1, it is going to uniquely determine a fundamental cut set, B2 is going to uniquely determine a fundamental cut set, and so forth. Okay, and that's what we saw here. So E5 determines this one, E3 determines this one. Okay, so let's look at the fundamental cut set determined by V1. Okay, and see what is going to happen. So here our aim is to prove that this Ci, it occurs in every fundamental cut sets associated with the branches in this fundamental circuit tau, in this case F, and in no other cut sets. Okay, so let S1 be okay this set B1. So C1, C2 up to some CQ or something like that. Okay, so let this set be a fundamental cut set, a fundamental cut set associated with okay, B1. So B1 from this one, so it will contain B1 along with some chords, and let the chords be say C1, C2 up to C2, consisting of say Q chords and the branch B1. Okay, now we can see that this B1 is in both S1 and F. So from the previous theorem we know that okay, a cycle and a cut set, with respect to a cut set and a cycle, okay, they have even number of common edges. Okay, so that we proved in the previous video. Okay, so now we can see that now the edge B1 is in both F and S1. Okay, and in an earlier video we proved that okay, there must be an even number of edges common in a cut set and a circuit. So as there must be an even number of edges common in a cut set and a circuit, okay, there must be at least okay, at least one more edge common in both F and S1. Okay, so here what we did is okay, with respect to this B1, okay, we chose a branch edge, we chose this S1. Okay, and we have this circuit. Okay, in this case it happened to be a fundamental circuit. Okay, but from a previous theorem we know that there must be an even number of edges common in a cut set and a circuit. Okay, so okay, here we chose this S1 to be a fundamental circuit with respect to this B1. So we know that this B1 is common to both F and S1. Okay, so we know that the edge B1 is in both F and S. Okay, and as there must be an even number of edges common in a cut set and a circuit, there must be at least one more edge common in both F and S. Okay, but here the thing is that here we have okay, one branch edge and a set of chord edges, and whereas if you look into this fundamental circuit, it contains a chord edge and a k number of branch edges. Okay, so something must be common means okay, this Ci, it must be equal to one of these Ci's. Okay, okay, so let's go and okay, so with that observation, but among the remaining edges in F and S1 only a chord can be common in both. Okay, so that Ci and any of this that okay okay, this Ci and any of these C1 up to CQ must be equal. That's what I am saying. Okay, so but among the remaining edges in F and S1, only a chord can be common in both. Okay, so S1 is this set, and now B1 is common to both S1 and F. Okay, B1 is common. Okay, so since we have this theorem, there must be an even number of edges common in a cut set and any circuit. Okay, there must be at least one more edge common in both F and S. Okay, there must be, other than this B1, there must be one more edge common. Okay, so here we can see that there is only one chord edge here, and here we have two chord edges. So that means that Ci must be equal to any one of these, C1, C2 up to Ck. Okay, and that says the chord Ci is one of the chords C1, C2 up to Ck. Okay, so we are able to show this thing. It occurs in every fundamental cut set associated with the branches in tau. Okay, and we have to, next we have to prove that okay, it does not appear in any other cut set. Okay. Okay, but among the remaining edges in F and S1, only one chord can be common in both. Okay, so therefore the chord Ci is one of the chords Ci, C2 up to Ck. Okay, so therefore the chord Ci is one of the chords C1, C2 up to Ck. Okay, so it must be equal to one among these things, C1 up to, sorry, I think Ck. Okay. Okay, so that says Ci is contained in the fundamental set S1 corresponding to the branch B1 of F. Okay, so we are all able to prove the first part. So Ci is contained in the fundamental cut set S1 corresponding to the branch B1 of F. Okay, and we can apply the same argument to B2, B3 up to Bk. Okay, so we will see that in every cut set determined by those edges B2, B3 up to Bk, this Ci is going to be an element. Okay, so the same argument holds for cut sets associated with these branches B2, B3 up to Bk. Okay, so that says that chord Ci, okay, it will contain in the cut sets defined by B2, B3 up to Bk. Okay, so that says therefore the chord Ci is contained in every fundamental cut set associated with the branches in F. Okay. The branches in F. Okay, so we proved this part. Ci, it occurs in a very fundamental cut set associated with the branches in this tau. Okay, so Ci will occur in the fundamental cut set associated with B1, B2, B3 up to Bk. So we proved for B1. The same argument holds for the other thing. Okay, so now we have to prove that this CI does not appear in any other cut set. Okay, so moreover we can see that if the chord CI is in any other fundamental cut set in T, okay, besides that associated with B2, B3 up to BK, okay, then there would be only one edge CI common to some other cut set Si and F. Okay, so anyway, let me write down what I am trying to say. Okay, moreover, so next what we are going to do is we are going to prove this one. Okay, this particular thing Ci, it does not appear in any other cut set. Okay, so moreover we can see that if the chord Ci is in any other fundamental cut set, say as S dash in T. Okay, so besides those associated with those B1, B2 up to BK, then we can see that there would be only one edge Ci, okay, common to okay, this cut set S dash and F. Okay, since none of the branches in F are in S dash. Okay, so moreover if the chord Ci is in any other fundamental cut set, say S dash in T, so this is S dash in T, okay, besides those associated with B1, B2 up to BK, then there would be only one edge Ci common to S dash and F, since none of the branches in F are in S dash. So it will violate this condition. So we have this thing, okay, there must be an even number of edges common in a cut set and a circuit. So here we have only one common thing, one edge Ci common to S dash and F. Okay, and the reason is since none of the branches in F are in S. Okay, S dash. So these B1, B2 up to BK are not in S dash. Okay, so but this is impossible. Okay, as there must be an even number of edges common in a circuit and a cut set. So this particular thing S dash and T. So here we have this, okay, another cut set S dash of T, and this F, it doesn't have, okay, it have only this Ci in common. Okay, and because and since we have this thing, there must be an even number of edges common in a circuit and a cut set, and here since there is only one common edge Ci in both S dash and F, okay, this particular thing is not possible. Okay, so okay, but this is impossible. Okay, as there must be an even number of edges common in okay, in a circuit. And a cut set. Okay, and here in this S dash, so moreover if the code Ci is in any other fundamental cut set S dash in T, okay, besides those associated with this B1 B2 up to Bk, then there would be only one edge, okay, Ci common to S dash and that fundamental circuit F. Okay, since none of the branches in F are in S dash. Okay, so all the elements are different from this thing. That's what this means. Okay, and since we have this thing, there must be an even number of edges common in a circuit and a cut set. Okay, this particular situation is not possible. Okay, so that says Ci it cannot be in any other cut set. Okay, so therefore this Ci is contained only in the fundamental cut set corresponding to the branches of the fundamental circuit determined by Ci. So Ci is contained only in the fundamental cut sets corresponding to the branches of the fundamental circuit determined by that code Ci. Okay, and that's what we want to prove. So okay, we proved these two things. Okay, this code Ci it occurs only in every fundamental cut set associated with the branches in this fundamental circuit and in no other cut sets. Okay, and that's the proof of this statement. So Ci is contained only in the fundamental cut sets corresponding to the branches of the fundamental circuit determined by, and hence the proof. Okay, so we are able to prove this one with respect to a given spanning tree T, a chord Ci that determines the fundamental circuit say tau occurs in every fundamental cut set associated with the branches in tau and in no other cut set. Okay, so we will prove the other thing in the next video. So in the next video we will prove this statement with respect to a given spanning tree T, a branch Bi. So we concentrate on branch Bi that determines the fundamental cut set S is contained in every fundamental circuit associated with the chord in the cut set S and no other. Okay, so that we will prove in the next video.